Today I am going to discuss some modern wireless communication systems. We can classify them as first generation, second generation, 2.5 generation, third generation, fourth generation, and fifth generation, which is available in South Korea. The examples of first generation systems are AMPS, that is Advanced Mobile Phone Service, and TACS, Total Access Communication Systems. The 1G or first generation mobile phone had only the voice facility. The limitations of 1G are it supports only speech, it has low traffic capacity, unreliable handover, long call setup time, frequent call drops, and inefficient bandwidth usage, and large size of the handset. The basic structure or architecture of the first generation is that it has a mobile user, a base station, and a mobile switching center. It has voice channels, voice circuits, and this mobile switching center controls the signals which has to be transmitted from base stations to the and from the base stations to the mobile users. The functions of the mobile switching center are to perform network management, call handling, and processing. The mobile switching center is interconnected with the public switch telephone network, that is PSTN, through the landline trunk lines. The second generation standard known as the Global System for Mobile Communication GSM. It emerged in Europe, and the US standards of TDMA and CDMA belongs to this generation. The other second generation wireless standards are British Codeless Telephone Standard, that is CT2, and Personal Access Communication System, PACS, and European Standard for Codeless and Office Telephony, that is Digital European Codeless Telephone, DECT. The 2G technology supports data, speech, fax, SMS, and other wireless application services. The 2G systems use digital voice coding and digital modulation. The systems employ dedicated control channels within the air interface for exchanging voice and control information between the subscriber, base station, and mobile switching center while the call is in progress. 2G systems are specifically designed to provide paging, fax, and high data rate internet access. The handoff process used in 2G is mobile assisted handoff. The 2G systems have been designed to reduce the computational and switching burden at the base station or the mobile switching center. The limitations of 2G are they have low data rates, that is 9.6 to 28 KB per second, and they used switched networks, and end systems are dedicated for the entire call duration, and inefficient usage of the bandwidth and resources. The generation between second and third is called as the 2.5 generation, and the technologies are GPRS, that is General Packet Radio Service, Enhanced Data Rates for GSM Evolution, EDGE. It uses Hypertext Transfer Protocol (HTTP) and Wireless Access Protocol, through which the web pages are viewed using the mobile phone. 2.5G is a packet switch network. The third generation network carry all types of information like voice, data, and video. The examples of 3G networks are PCS, that is Personal Communication System, IMT 2000, that is International Mobile Telecommunication, and UMTS, that is Universal Mobile Telecommunication Systems. UMTS is also known as wideband CDMA. The 3G operates in the 1710 to 2170 MHz band. 3G was launched in 2000 and it offers high-speed data, speed of up to 2 MB per second, and they have increased bandwidth and higher data transfer rate, broadband applications, and faster downloading. These are the main advantages of 3G. The 4G technology is the extension of the 3G technology, that is having more bandwidth services. The speed offered is around 10 Mbps and up to 1 GB per second. The commercially available technologies were the WiMAX standard and the LTE standard. 4G allows for video conferencing, streaming, picture perfect video for telemetric applications. OFDMA multi-carrier transmission methods, frequency domain equalization, multiple input, multiple output, and turbo code techniques are used in 4G networks. One of the most important aspects of 4G is that the elimination of parallel circuit switched and packet switched network nodes by using Internet Protocol version 6, that is IPv6. The currently So we can compare the various generations starting from first generation to the fourth generation. The first generation began in the 1970s and the fourth generation in the 2012, and the services provided by first G were analog, and presently in the 4G we have high capacity digital networks and multimedia systems. The bandwidth used in 1G were in the range of 1.9 kb per second, and presently we have a speed of 200 Mbps. And the core network began with PSTN, and presently the internet is the backbone of the 4G network. Wireless local loop. It is an IEEE 802.16 standard, and it provides voice and data communication to the end users with increased capacity. In this, each cell will include a base station antenna, and individual subscribers have fixed antenna that has unobstructed line of sight to the base station antenna. From the base station, there is a link to the switching center, and the switching center provides connections to the local and long distance networks. The advantages of wireless local loop are less expensive, less installation time, wide channel bandwidth, high data rate, small size antenna, and selective installation. Thus, the WLL is a cellular like phone without mobility. These are designed for fixed communications. The subscriber unit is fixed like a wireline telephone, and the local loop between the exchange and the subscriber home is replaced with a wireless link. Wireless LAN or WLAN. It is an IEEE 802.11 standard. It is a wireless computer network, and it links two or more devices using wireless communication to form a local area network within an area such as school, office, etc. The advantages are easy to add or remove workstations, easy to provide connectivity, installation is easy. A WLAN allows users to move around the coverage area while maintaining the network connection. The types of WLAN are peer-to-peer, that is, it allows wireless devices to directly communicate with each other. And the second type is bridge and Ethernet bridge, which act as a connection point to the wireless LAN. Frequency hopping spread spectrum and direct sequence spread spectrum were used in the early IEEE 802.11 standard. Later, the DSSS IEEE 802.11b has been named as Wi-Fi personal area networks. That is the within the range of 10 meters, persons using laptops, personal digital assistant, and a portable printer, they can interconnect without having to plug in anything by using some form of wireless technology. A PAN is centered around one person while WAN serves multiple users. PANs can be constructed with cables or wireless USB. Wireless PAN uses Bluetooth or infrared connections. Bluetooth PANs are also called piconets. Bluetooth is a short wireless communication technology that allows devices such as mobile phones, computers, and peripherals to transmit data or voice wirelessly over a short distance. Bluetooth operates in the 2.4 GHz band. It uses frequency hopping spread spectrum technique. The standard is IEEE 802.15 and the modulation used is Gaussian frequency shift keying with a data transfer rate of 1 MB per second. WiMAX Worldwide Interoperability for Microwave Access. It uses universal delivery of wireless broadband service for fixed mobile users and standard is IEEE 802.16 and it uses OFDMA. It is also known as wireless metropolitan area networks. It provides broadband wireless connectivity over a large geographical area such as a metro city. Mobile WiMAX is based on IEEE 802.16e. It provides mobility and roaming access. The frequencies used for 802.16d are 2.3, 2.5 and 3.5 GHz and used for 802.16d are 3.5 and 5.8 GHz. The overall network can be divided as mobile station, access service network and connectivity service network. The mobile station is used by the end user. The ASN comprises one or more base stations and gateway. The base stations receive data from one or more mobile stations and data from the base station is given to the ASN GN through access network.